red dwarf stars might be killing alien forests before they ever grow. 7 out of every 10 stars in our galaxy are red dwarfs. That means the overwhelming majority of rocky planets we've ever discovered orbit these tiny, dim, reddish stars. So if alien life exists anywhere out there, statistically, it should be around a red dwarf. But here's the problem, and it's a big one. A new study just dropped that says those stars might be feeding their planets junk food light. Photons that look fine on paper but can't actually do the one job that matters most for complex life: split water apart. And if you can't split water, you can't get oxygen. No oxygen, no forests, no animals, no civilization, possibly no detectable life at all. So are we searching in the wrong places? Let's break it down. The study comes from physicists Giovanni Covone at the University of Naples and Amedeo Balbi at the University of Rome Tor Vergata, published as a preprint on AR14 in February 2026, and submitted to the journal Monthly Notices of the Royal Astronomical Society. And their core argument flips the script on how we think about habitable zones. See, when scientists talk about a star's habitable zone, they usually focus on quantity: how many photons reach a planet's surface, specifically in the visible light range between 400 and 700 nanometers. If the numbers check out, the planet gets a thumbs up. But Covone and Balbi are saying, hold on, we need to talk about quality. They use a concept from thermodynamics called exergy. Think of it this way. You could fill a swimming pool with lukewarm water or with the same amount of scalding hot water. Same volume, wildly different usefulness. Exergy measures how much actual usable work you can squeeze out of a radiation field. Not just the raw energy, but the fraction that can drive real chemistry. And the chemistry that matters most here is called water oxidation. It's the step in photosynthesis where a plant literally rips water molecules apart to release oxygen. On Earth, this is the engine behind our breathable atmosphere. It powered the Great Oxidation event roughly 2.4 billion years ago, when cyanobacteria flooded our skies with oxygen for the first time, eventually making complex multicellular life possible. But here's where red dwarfs fall short, twice. First, because they burn so much cooler than our sun, their light skews heavily into the infrared. Most of those photons just don't pack enough punch to reach the energy threshold needed to crack a water molecule. And second, even the photons that do clear that bar carry a smaller fraction of convertible, useful energy. It's a double penalty. According to the study, the usable energy available around sun-like stars for this critical reaction is about 5 times higher than around red dwarfs with surface temperatures near 3000 Kelvin. Now, you might be thinking, couldn't alien plants just adapt? Evolve to use infrared light instead? The researchers actually address this directly. There's a concept called the red limit, which is the longest wavelength of light that can still power photosynthesis. And their calculations show that for red dwarf planets, that limit sits around 950 nanometers, while sun-like stars push it closer to 1000 nanometers. That's not enough of a difference for life to compensate by shifting its absorption deeper into the infrared. And it actually gets worse. Bacteria that don't produce oxygen, anoxygenic photosynthesizers, are great at harvesting infrared light. On a red dwarf world, these microbes could dominate the planet's surface and outcompete any oxygen-producing organisms before they ever get a foothold. The planet might never experience its own version of Earth's Great Oxidation event. Without abundant oxygen, multicellular life would face an enormous barrier, maybe an impossible one. Now, does this mean life around red dwarfs is completely off the table? Not necessarily. Earth's biosphere currently operates thousands of times below the theoretical thermodynamic maximum for photosynthesis. Life is staggeringly inefficient, which means there is a window. But that window around red dwarfs is extremely narrow. The real takeaway here is that this research could reshape where we aim our telescopes. Instead of chasing biosignatures around the most common stars in the galaxy, our best shot at finding oxygen-rich alien worlds might be around stars more like our own sun, the G-type and K-type stars that pump out higher quality light. What do you think? Should we keep searching red dwarf systems? Or is it time to redirect the hunt? Drop your take in the comments. And if this changed how you think about alien life, hit subscribe so you don't miss the next one.